Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's the problem for today for exam P on probability. X and Y have a bivariate normal distribution with mean of x equal to 0, mean of y equal to -1, and the expected value of xy equal to 1. If the expected value of y given that x is 2 is equal to 1, and the expected value of x given that y is 0 is 1/16, find the variance of y given that x is -2. And here's the solution. So let us write e of x to be mu x, e of y to be mu y, variance of x sigma x squared, variance of y sigma y squared, and note that the expected value of xy is 1, expected value of x times expected value of 1 is 0, as well as rho, the correlation coefficient, which is covariance of xy over square root of variance of x times variance of y, is equal to, which is equal to e of xy minus e of x times e of y over sigma x times sigma y. Well, the top is 1, so the bottom just stays as it is. This is equal to 1 over sigma x times sigma y. But now recall that e of x given that x is equal to x is mu y plus rho sigma y times x minus mu over sigma x. That's a very important formula about the bivariate normal distribution, one of the key properties of the bivariate normal distribution, and you must remember that. The conditional expectation of one variable given the value of another variable is a linear function of that value on which the conditional expected value is based. So given that x is equal to x, that value is a linear variable in this formula if you treat it as a variable. So we plug in what we have for expected value of y given that x is equal to 2. That's given as 1, but it's also equal to -1 plus 1 over sigma x times sigma y times 2 over sigma x. And that is equal to just -1 plus 2 over sigma x squared, because sigma y cancels in the expression that you have there. And from this we calculate that sigma x must be equal to 1. If 1 is equal to -1 plus 2 over sigma x squared, then 2 is equal to 2 over sigma x squared, so that sigma x squared is equal to 1, and standard deviation is the square root of the variance, so it's 1. Furthermore, expected value of x given that y is equal to y is mu x plus rho sigma x times y minus mu y over sigma y. And again, we plug in what we have about the expected value of x given that y is equal to 0, which is 1/16. And that's going to be equal to 0 plus 1 over sigma x times sigma y, rho, that's what we calculated to be, times sigma x, times 0 minus -1 over sigma y, so this is 1 over sigma y squared. And then sigma y has to be 4. This implies that rho, which is 1 over sigma x times sigma y, is 1/4. And another formula that you need to remember about the bivariate normal distribution, variance of y given that x is equal to -2, well, that's actually always equal to 1 minus rho squared times sigma y squared. And we just plug in the values that we know. That's 1 minus 1/16, because the square of 1/4 is 1/16, times 16, and that's equal to 15. And this is answer E. Please remember this is copyrighted material. That problem was created by me and solution is mine. All rights reserved for production in whole or in part without express written permission from the author is strictly prohibited.